Well, I'm delighted to be here. And Rob is exactly right. I'm a basic neuroscientist who spent 30 years only working in the lab, studying how experiences change brain function. Literally, we would take experimental animals, my lab used non-human primates, and give them different experiences and see how that changed the structure of the brain. But a real life-changing experience was explaining that research at the MacArthur Foundation in Chicago and having everybody around the table say, wow, are you saying that experiences don't just change how people behave, they actually change the brain? And I was really quite startled by that. Of course, if they change how you behave, what's controlling how you behave? Your brain. So of course they change the brain. But that wasn't the general way that people thought about it. They thought that you have a whole repertoire of ways of behaving and you could behave any way you wanted to. Not that the structure of the brain was actually controlling your behavior. So I showed lots of pictures that experiences change brain structure, they change gene expression in the brain, what the code that the brain is using to determine what to do, and that caused a change in behavior. And they convinced me that I should go on the road part of every month. So they gave me some training in public speaking, and I've talked to state legislators a great deal of the last 20 years. I try once a month to go out and talk to a legislature about how important it is for early brain development and for resources to be there to support early brain development, things that you're interested in. And I have a pretty good track record with that nowadays. And after having done that for about 15 years, about 5 years ago, I started to take over science outreach for the University of Pittsburgh. The University of Pittsburgh actually owns an 80-foot truck, and it's outfitted as a lab. And so it drives up to a school, 30 kids can get on, and they have counters, and they can look under the microscope, and they can figure out what's going on. And that lab travels all over rural Pennsylvania, West Virginia, Ohio, and delivers state-of-the-art science experiments to communities who would otherwise not have that ability, and sees about 20,000 people a year. And occasionally I go out with the lab to see how new experiments are working. And while I was out with the lab, I would ask parents who would come to see what their kids were doing, so how's your kid's brain development? And they would just look at you like, what? What are you talking about? What do you mean, how's my kid's brain development? It's just developing. And so I realized that we might be getting the message about how early is really important and how you need really important early life experiences to set kids on a good trajectory for health, for well-being, for doing well. We were getting that message to legislators, to professionals, but we're not getting it out to the public. And so for the last several years, I have spent a lot of time translating the information that I get in the lab and that we have spent a lot of time developing. You'll see that I'm a member of the National Scientific Council on the Developing Child out of Harvard University. We write short papers, summaries, we make videos. We have even made games that teach about brain development. But those are not tools that get the message out to the public. And so today, I've been given the mission of telling you what is the science, what's the brain development behind everything you're going to be talking about for the next 2 days. Why do early experiences matter? And hopefully I'll convert you a little bit to being neuroscientists and understanding brain development. But in the process, I'm going to use a variety of tools. So I'll use tools I use all the time that are freely available to you if you want to use them. You go to the council's website and you can download all the working papers, all the videos, everything that we've produced, as well as Working for Kids materials, which is how we take this information to the public. So you've already heard Dr. Carlson, who I think very nicely summarized that the early years are incredibly important. They're not only important for developing so that you have very good health, but also for developing your ability to do things and your ability to achieve. I'm going to cover 4 topics. I'm going to do it pretty fast. I've promised Rob I'll absolutely keep an eye on the clock and stay on time. But what we're going to talk about here is we're going to start by talking about the fact that brain architecture is established early in life. Those are the pathways between brain cells. And you'll understand, I think, how genetics affects that, but also how very, very important life experiences are. We're then going to talk about early life adversity and how exactly does that work? How does that get into the brain and change the brain? We're going to talk about the fact that neural circuits can be strengthened to improve a whole series of skills here, which Dr. Carlson referred to as executive function skills. I'm going to reiterate her message and say these are incredibly important. And in fact, the brain pathways for these are still developing until a child is somebody we wouldn't call a child, a 25-year-old. They're still building brain pathways for those executive function skills. So there's a long time for all of us to have an impact on those skills. And lastly, the social support systems, both individual social support systems and community social support systems, are incredibly important for guiding a child's brain development. So I'm going to start with some material that we use in the community because we generally have a hard time convincing people to start with that experiences have any effect at all. They say, children smart with little brains, I don't do anything. They just grow up and then they're ready to go to kindergarten. Their brain just develops all by itself. It's 100% genetic. And that couldn't be more wrong. And you will learn a very good comeback for this in just a few minutes. But we start with telling a story. And we use this graph, which is actually a graph from Dr. Huttenlocher, which was published in 1991, which shows the rate of vocabulary size development based on how much mother's speech there was. So she studied many children, she quantified the level of mother's speech, and then quantified how fast the children had an increase in vocabulary. But rather than explaining that to the public, because they could care less about scientists and how they make graphs and how they do studies, we talk about these 2 little boys here. So this boy, Darren, look at his mom. What does his mom do? His mom is a hairdresser. So how many of you go get your hair cut? I bet almost all of you. I don't see anybody with really long hair. Of course you don't. Anyway, for all the rest of you in the room, when you go get your hair cut, do you talk to the person cutting your hair? Your barber, your hairdresser? Yeah, they talk nonstop. Well, so does Darren's mom. She talks to everybody. And so when he's born, she starts talking to him, not at 12 months when he starts talking. The minute he's born, she starts having conversations with him. And her friends make fun of her. They're there. You can't, he's not going to answer you. What are you doing? And she goes, I'm just so excited he's here. I want to make sure he knows it. And she talks and talks. Her friends come over. Everybody talks. This child is exposed to a lot of vocabulary. We now know, and we can study the parts of the brain that are important for communication. We know they're already forming prenatally, let alone in those first few months of life. The hearing of vocabulary, the interaction with a child, the one-on-one interaction, so that you're looking at the child and you're getting a response back and the child is learning that words reflect communication, is incredibly important. By the time he's 2, he's expected to have about 600 words in his vocabulary. Now, his next door neighbor is Robert. Robert's mother is a dental hygienist. Have you ever had a long conversation while you're having your teeth cleaned? No. And she is well educated, but she's a quiet individual. And she does not start talking to Robert when he's born, and she has quieter friends, so he's not exposed to as much language. By the time he's 2, he's expected to have 150 to 200 words in his vocabulary. And you might be thinking, they're 2 years old. It's not a big deal. Robert can just jump up to this level. But research, both by Huttenlocher and a number of other labs after Huttenlocher, has shown that children don't jump from one trajectory line to another. They continue to increase their language. They continue to be able to talk and communicate, but Darren will always have a larger language, and speaking and communicating will be easier for him. It's a very good example of how early experiences change a developmental process. And this particular developmental process matters a lot. Think of what happens when they get to school. Darren will be more likely to interact with other kids, to interact with the teacher. I was a talkative little first grader. I can tell you talkative little first graders are more likely to interact with the principal also, and to get in trouble. Yeah. But nevertheless, they interact a lot. So being communicative does a lot for them. Now, Robert may be very good at a large number of things and doesn't need to communicate to be very good at those, but communication will always be a little more difficult. This type of story, we have discovered, really opens up an audience to being accepting that, okay, maybe experiences matter a little bit for brain development. They matter for health also. If we look up here, we're looking again, Dr. Carlson showed you some data from ACEs, Adverse Childhood Experience Studies. This is from the original ACEs study. And you're looking at the odds ratio of a person my age having a heart attack. And you might think that's mainly due to genetics. If we look at an odds ratio of 1, that would be my genetic predisposition. It may be due to, am I healthy? Am I eating well, exercising well? But what you're looking at is how many adversities children experienced. And children that experienced a large number of adversities in their early childhood have a 3-fold higher rate of having a heart attack in their 50s and 60s. It's a whopping effect of something that happens early and then somehow gets encoded in the brain and the body so that it sticks with you. We're going to talk about exactly how this happens. So they did invite a neuroscientist to talk to you, and you're looking at drawings of neurons. At birth, you're born with virtually all the brain cells you're ever going to have in your brain. You don't get new brain cells, even though your brain gets much larger. There's one little area of the brain that gets new cells. Scientists are still debating how effective they are. But for the vast majority of your brain, you don't get new cells. What happens is when this brain area starts developing, it's genetically programmed to reach out connections, extensions, and connect to other cells. So when this brain area is 3 years old, it's at its peak of being plastic, is what scientists say, so it's changing the most. There are a huge number of connections. But if we look at that same brain area at age 14, we see there are many fewer connections. The connections are stronger, but there aren't as many. Now, you should be asking, what happened to all these connections? And what determined which connections would stay and which connections would be pruned? And that's 100% experience. So we teach parents to have model neurons. Here's your 2 model neurons. When your brain area is ready to develop, it is genetically programmed to reach out extensions, connect to each other, and the normal process of development is that many connections are pruned away. What determines which ones stay and which ones get used? The ones that stay are the ones that get used. So, experience and things that children are doing are incredibly important. They determine which connections will stay and how many connections will there be in that pathway. Different areas of the brain develop at different times. What we're looking at here on the upward swing is the development of connections, and on the downward swing is the pruning process. So areas of the brain that control sensory pathways like vision, hearing, taste, smell, they start making connections prenatally before the child is born. And the first year of life is incredibly important because that's when experiences will have some pathways being used and they'll stay in the brain. Language is making connections through the middle of the first year of life, and then pruning occurs till around age 7. That means you can build extra pathways for communicating well if you do so in the first 7 years. That's the plastic period for that brain area. Now, different languages make different sounds. So if you had Spanish like I did in high school, if I spoke Spanish to you, you'd say, she learned Spanish past the plastic period, because I don't sound like a native Spanish speaker at all. But I did really well in Spanish. I had 4 years of it. And then I lived in graduate school in Arizona where I had more exposure. But I don't have customized brain pathways for making sounds that are made in Spanish. So we should be teaching our schools. I'm very glad you're having a whole session tomorrow on K through 12. Our schools should not be spending money in high school on teaching languages. They should be spending money in preschool on teaching languages. You're the economists here. It would be easier. What does that translate to? Even I know that means is less expensive, right? And more effective, so that you would have children that can speak multiple languages who could sound like native speakers, and it would have cost you less money. But no, we still offer it in high school. So I'm hoping you can have an impact tomorrow on that. Higher cognitive function is completely different, and it is making connections for the first 10 to 12 years of life, and the pruning goes on till about age 25. So these are executive function issues. It's the front part of the brain sending processes back to the rest of the brain, and you're able to influence it by experiences that kids have later on.
A child's experiences during the earliest years of life have a lasting impact on the architecture of the developing brain. Genes provide the basic blueprint, but experiences shape the process that determines whether a child's brain will provide a strong or weak foundation for all future learning, behavior, and health. During this important period of brain development, billions of brain cells called neurons send electrical signals to communicate with each other. These connections form circuits that become the basic foundation of brain architecture. Circuits and connections proliferate at a rapid pace and are reinforced through repeated use. Our experiences and environment dictate which circuits and connections get more use. Connections that are used more grow stronger and more permanent. Meanwhile, connections that are used less fade away through a normal process called pruning. Well-used circuits create lightning-fast pathways for neural signals to travel across regions of the brain. Simple circuits form first, providing the foundation for more complex circuits to build on later. Through this process, neurons form strong circuits and connections for emotions, motor skills, behavioral control, logic, language, and memory during the early critical period of development. With repeated use, these circuits become more efficient and connect to other areas of the brain more rapidly. While they originate in specific areas of the brain, the circuits are interconnected. You can't have one type of skill without the others to support it. Like building a house, everything is connected, and what comes first forms a foundation for all that comes later.
So that does a fairly good job of explaining to professional audiences how brain development works. And you just need to know a couple things. Kids need to have experiences for building specific circuits. You need to know when the plastic period is for that circuit. And there are hundreds, if not thousands, of brain areas, each with their own developmental time course. However, going out into the community and getting the community interested in hearing a lecture from somebody like me, or reading a handout, or even getting a movie, these movies are freely available, is almost impossible. You really can't get people in their regular lives to do that. So we've made some materials. This retractable poster can be taken anywhere. It doesn't need electricity. And we can tell stories and have hands-on activities that people can do to learn this information. And this is very, very effective in getting people to understand brain development. So we would start by saying that the back part of the brain controls vision. We have a picture of eyes. We get people to put it up there. It starts developing prenatally. It has a very short period of development, so it's finished developing by about 1 year of age. If we look at something else that develops really quickly, and children cry immediately after they're born, and the ability to express emotion and to recognize emotion is controlled by an area of the brain that's here. A scientist might talk about the amygdala, but we don't talk about the amygdala when we're in a community. We just put a picture of a child frowning there. The area that controls communication is located right above that. It starts developing connections prenatally and finishes pruning at about 7. And motor pathways are up here. Again, they develop from prenatal till about 5 years of age. The front part of the brain has a very different time course of development. It's making connections till about 12, pruning until about 25. We then give people very sophisticated scientific material here. And we let them think about how are they going to get kids to have experiences that will build connections. So let's go back to Darren and Robert and think about reading. To read effectively, you would need to have a connection between the part of the brain that controls vision and the part of the brain that controls communication. How are you going to encourage reading? Many people say, well, I'd read to the child. And that's a great idea. So reading to the child will strengthen pathways, but they have to use the pathways themselves. It doesn't work just to listen to reading. They have to be excited about it and do it themselves. So how else are you going to do that? Well, you're probably going to go get books that they really like, maybe get them a library card so they can pick out books they really like. You might encourage them to read to their brothers and sisters, or my first daughter would love to read to her stuffed animals. She'd line them all up and read to them. You want to figure out for every single child, what are you going to do that will really encourage them to use that pathway again and again, because the more it's used, the more permanent it will be. How many times do you have to do this? I have parents all the time who say, well, I'll read to my child every night for 7 years, and they're very proud of themselves. And I say, 365 times 7, we're at about 2,500. Not nearly enough. You need to use brain pathways, scientists estimate, at least 10,000 times to have really strong permanent pathways. So you have to think of many things, and it has to be individually tailored to each child so that that child will be encouraged. Now, something that adults don't like to think about is that things children do all the time are going to cause good brain development and sturdy brain pathway development for whatever they're doing all the time. It doesn't have to be something that adults are really in favor of. So so let's think of a child growing up in a household where they're faced with an angry adult. They're living in a situation where somebody has trouble controlling anger. And this happens, it turns out, a lot. They become very good at recognizing anger. And then most children will get out of the way. How often are they likely to experience somebody who has trouble controlling anger? Very, very often. If they're living in a situation where they see that all the time, it can be a daily occurrence. It can be something more than a daily occurrence. And so these pathways are being built in the first 5 years of life, and they are going to be very strong and permanent. Think about what that means. It's fantastic for that young child. They see anger, and they get out of the way, and they have strong brain pathways to allow them to do that fast. That will protect them. The brain is always trying to do the best for the child, develop strong pathways for what the child is using. However, what happens when they get to be a teenager? Let's say at their first job, they're late for work, and their boss gets mad at them. What are they likely to do? Possibly just leave. Possibly not know how to stand there and take a boss getting mad at them and face up to the situation. So it worked really well at one point in their life. The brain doesn't know the child is going to have different experiences later on. It strengthens pathways that work for what is happening then and now. Now, the good news is we still have a part of the brain developing for that teenager. Those front pathways are developing. What are they doing? They control every other part of the brain. So what we'd really like to see is this child rethinks the situation. Why is my boss angry with me? What could I do about it besides running? And if they use this pathway again and again, it will become strong, and they'll rethink what to do about anger. And they'll be able to use that in their adulthood. They may also think about how to change what they do in response to anger. And if they do that again and again, they'll use it. The problem here is, to make strong pathways, you have to use them a lot, about 10,000 times. And it's much more difficult to get teenagers to want to use those pathways over and over and over again. So we have actually started to develop a number of games and a number of tools for teens. Even though I'm here talking to you about early brain development, you can't ignore the fact the brain continues to develop through the teenage years, and it's important to strengthen those pathways also. Using tools like this that people are allowed to use and manipulate does a really good job of teaching them what you're trying to tell them. So we're going to go on from there and mention quickly that the way that you get kids to do different experiences, and especially at particular times when it's critical for brain development, is through interactions with others, and especially interactions with adults.
The key to forming strong brain architecture is what's known as serve and return interaction with adults. In this developmental game, new neural connections form in the brain as young children instinctively serve through babbling, facial expressions, and gestures. And adults return the serve, responding in a very directed, meaningful way. It starts very early in life, when a baby coos and the adult interacts and directs the baby's attention to a face or hand. This interaction forms the foundation of brain architecture upon which all future development will be built. It helps create neural connections between all the different areas of the brain, building the emotional and cognitive skills children need in life. For example, here's how it works for literacy and language skills. When the baby sees an object, the adult says its name. This makes connections in the baby's brain between particular sounds and their corresponding objects. Later, adults show young children that those objects and sounds can also be represented by marks on a page. With continued support from adults, children then learn how to decipher writing and eventually to write themselves. Each stage builds on what came before. Ensuring that children have adult caregivers who consistently engage in serve and return interaction, beginning in infancy, builds a foundation in the brain for all the learning, behavior, and health that follow.
So, one of the problems with stress is, and you've already learned something that stress does, when you think of the red brain pathway, one of the key things that stress does is stress gets children to utilize and strengthen different brain pathways. And so maybe they'll spend less time focusing on learning to talk or learning to read or learning to problem solve, and more time focusing on understanding the emotions that are going on around them or learning how to get out of the way. It's not that they stop developing strong brain pathways. They develop strong brain pathways for different things. That's one way in which stress works. You already should be able to deduce that different parts of the brain are going to be affected by stress at different times during development. And that's because the neural circuits that are plastic are responsive to stress. The ones that developed already, they're not so responsive to the environment. They're not going to be responsive to stress. The ones that are going to develop later, they're not going to be so responsive to stress either. Stress that happens is going to affect predominantly the circuits that are plastic right when the stress is happening, because the child's attention will be diverted away from using those brain pathways. I get asked all the time, well, I have 2 children. They experienced the same family trauma. One was 2 and one was 5. Why did they respond so differently? And I'm thinking, Of course they responded differently. They have completely different sets of brain pathways that are forming. The brain pathways that are forming right when the stress is experienced are the ones that are going to be sensitive. So you can have stress, your brain is developing all the way through childhood, adolescence, into adulthood. 25 is certainly adulthood. You should remember two things about the impact of stress. It's cumulative over time. It's cumulative over time because, let's see if I can go backwards, because stresses are embedded in sensitive periods. So if you experience multiple stresses, multiple circuits are going to be influenced by that stress. I have talked to you a lot about how experiences impact brain architecture. Experiences also impact gene expression. And people think, I don't get that. I'm born with all the genes I have. And you are. Every cell in your body has a full complement of genes. However, every cell doesn't use all your genes to direct its business. It just reads some of the genes, and the other genes are silent. What experiences do is they turn on and off genes. So different genes can be used to direct the business of a brain cell if you've experienced stress. You also have the effect of stress to lead to stress hormone secretion, and that can have lasting impact on brain cells. And lastly, stress changes the way you see the world. And I'm just going to show you one slide about that. And this is work done by Seth Pollack at the University of Wisconsin. What he did is he took pictures of adults. And so a picture of a happy face and the same adult making a fearful face. And then he fed these two pictures into the computer, and the computer made all the rest of those pictures by taking 90% of the pixels from the happy face, 10% from fearful, and so on. He did this with different expressions. He then brought normally developing children into the lab, and he said, where does the face turn from angry to fearful or angry to sad? And children picked out the 50% point really reliably. People are really good at doing this. However, when he brought children in who had faced a lot of anger early in development, they were super good at detecting anger. Remember this red circuit here. They have really strong circuits for doing this. They say the face is angry all the way up to here, and then it turns fearful. What does that mean? It means that I'm looking out at a sea of faces. The only slightly concerned face I see is Rob's, who says, don't go too long. But I don't think you're angry. You look serious, but I think you're paying attention. But if I'd experienced a lot of anger in my life, I would interpret it as you being angry with me. Do you think it's going to affect my health if every day of my life I see more anger than other people? You bet. And we now have really good data that you'll have a higher incidence of mental health disorders, a higher incidence of addictive disorders, higher chance of heart attack, higher chance of obesity, and almost all of the major life-threatening illnesses are affected by that kind of adversity and how you see the world. So there's 4 reasons that early life experiences get embedded into the brain: the architecture, the gene expression, the hormone secretion, and changing how you see the world. What we think is that we want to provide a whole series of programs, many that you're going to talk about today, to improve trajectory of brain development. Significant adversity impairs health development, unfortunately. What we want to put in place is new preventative interventions that would block those effects of adversity. We think about this as a scale. You have bad experiences on this side, you're going to tip to have negative outcomes. You have good experiences on this side, you'll tip more positive. So, what we're starting to realize is it isn't a simple matter of positive and negative experiences. What matters is the fulcrum. What matters is what's inside. Do you lean toward being more sensitive to positive experiences, or do you lean to being more sensitive to negative experiences? And I'm going to finish exactly where Dr. Carlson started, basically, saying capabilities that help with stress management, these front cortex activities, executive functions, self-regulation are particularly important, and they're continuing to develop into the 20s. So Working for Kids thinks that this is an entire community responsibility. Educating people, you educate the parents, and that's very good, but sometimes the parents aren't there. And so the entire community really needs to take responsibility for giving kids positive brain-building experiences. Thank you.